Hello guys, welcome to our channel. So today in this video we're going to talk about a very special uh, topic, H parameters and transistors, and this is for the upcoming csir-net 2020 September. This topic is basically an unexplored topic in csir-net. Students generally don't cover this topic, but I think this time in the csir-net 2020 September, one question you can expect from H parameters. Although this topic is very complicated, uh, but I would recommend you to do at least the formula. So here in this video I'll be giving you the formula sheet which will help you to solve or tackle problems from H parameters. And simple problem will come from it. If you know the formula, you'll be able to solve the problem. Okay, so without any wasting much time, let's start. Before guys, if you are not subscribed to the channel, please subscribe to the channel. Don't forget to press the bell icon. So we'll start with the basic C amplifier. You can see this is the basic C amplifier, and the topic of our discussion is analysis of a C amplifier using hybrid model. Now this C amplifier, you can see this is an NPN transistor, this is a collector, base and emitter, and an equivalent circuit of this C amplifier is written in the hybrid model for small signal. Okay, for small signal analysis we use this hybrid model, and we have taken C mode. You know, three modes are there: common base, common emitter, common collector modes. So you can see here the H parameters HIE, HRE, HFE and HOE. So we'll be getting some formula involving these H parameters, and as you can see, this Vs is the input, Rs is the internal impedance, and HI, you can say this is the input impedance, okay, Zi. And on the other hand we have RL, okay, output impedance. 1 by HOE is there, and HFE into I is there. So this is kind of output section, this is the input section. As we are interested in AC quantities only, the DC sources and coupling capacitors are short circuited. That is okay. Now let's come to the formula. The formula number one, current gain, AI. It is defined as the ratio of the output load current to input current. And as you can see, the formula AI is equals to IL by II. This is equals to minus I0 by II. Okay. If IL is flowing in this direction, IO is flowing in the opposite direction. So if when you are using IL, that is okay. When you are using IO, you have to use a minus sign. So that is formula is minus HFE divided by 1 plus HOE into IL. If HOE, this term is not there, then this will be 0. So this will be only minus HFE. And input impedance, it is the ratio of the input voltage to the input current, VI by II, which is given by HIE plus HRE into AI RL. HI is the input impedance, HRE is the reverse voltage gain. Similarly, voltage gain is the ratio of the output voltage to the input voltage, and it has the formula minus AI into RL by RI. Minus AI is the current gain, as you have already talked about. RL is the load resistance, and this RI is the input resistance, HIE and RS if there is any. Output impedance, Z0 is it is the impedance measured between its output terminals with the input replaced by its internal impedance. The formula is Z0 equals to V0 by I0, 1 by HOE minus HFE HRE divided by HIE plus RS. Power gain, it is defined as the ratio of the output power to the input power, and it is the ratio of output power by the input power, and it is given by the product of current gain and voltage gain. So now let's see what kind of question you got in the previous year. So this is given in csir-net June 2012. The transistor in the given circuit has HFE is equals to 35 ohm, HI equals to 1000 ohm, load resistance RL equals to 1000 ohm, voltage and current gain R. Okay, so things are given pretty simple. So we can utilize directly the formula. So what is given first, which we will write. So given HFE, this is equals to 35 ohm, HIE equals to 1000 ohm. This is the input resistance, you can say, and moreover RL also, and which is also equals to 1000 ohm, fortunately. So you have to find out the voltage and current gain. So voltage gain, you can see, dependent on the current gain in the formula. Why? In the formula. So first of all we will calculate current gain. Current gain is given by AI. So what will be the formula? Minus, what is the formula? We have seen the formula. Current gain is equals to IL by II. Okay, so this is IL by II, and this is equals to minus HFE, because HOE is not there, so this becomes minus 35. So your current gain becomes minus 35. Let's talk about the voltage gain. What will be your voltage gain? Voltage gain is given by AB, which is equals to minus AI into RL by RI. As you can see in this formula, AB is equals to minus AI into RL by RI. So AI we have got minus 35. RL is given to you 1000 ohm, divided by RI is HIE, means 1000. So this is coming out to be 35. And if you look at the options, you have been asked first voltage and then current. So plus 35 minus 35. So option B is found to be correct for this question. Okay. So option B is the correct option for this question. I hope you have understood this question very well. If you have not understood any part, you can let me know in the comment section. Before I end the video, let me just tell you guys, you can join me on Unacademy Plus if you are preparing for csir-net 2020 September examination. You can have a look at all my courses. It is available at unacademy.com/physics hub. You can get all the detailed courses like mathematical physics, classical mechanics, electromagnetic theory, quantum mechanics, and many more. All the 9 units you will get by just taking only one subscription. And this special offer is going on. You can get 20% off on your csir-net subscription between this July 18 to 22. So this is the last day, so you have to take it by today. You can utilize our referral code physics hub for getting this discount. And you can see the spelling PHYSICHU. This is also a channel without any spacing. And this is all for this video, guys. I hope you find this video useful. If you are new to this channel, please subscribe the channel. Don't forget to press the bell icon. And finally, guys, we'll be taking a special class on Unacademy app, Unacademy Special, which is free for everyone. You can join me on 22nd of July, okay, Friday at 9 a.m. So there we'll be discussing the advanced electromagnetic theory, advanced electromagnetic problems actually with detailed solutions. So see you there, and I'll be giving you the links in the description, so you can enroll from there and you can attend the live class freely. Thank you. Bye. Take care.